Hello everyone. So far we have learned how to create classes, create objects, access object attributes and define methods. We also understood that every object has its own data and methods allow an object to perform specific actions. But here an important question. What happens if an object information changes after it is created? For example, a student's grade may improve after an exam. A bank account balance changes after a deposit. Or a car color changes after repainting. Do we need to create a new object every time this information changes? The answer is no. Instead of creating a new object, we can use methods to update or modify the existing object's attribute. This makes our program more efficient, organized, and closer to how real world objects behave. In this topic, we will learn how methods can modify object attributes using the self keyword. Understanding the complete workflow with practical example. So let's get started with modifying object attributes using methods. So let me Instead of creating a new object every time something changes, we can use methods to update the object's attribute. Why use methods to modify attributes? Methods inside a class can read an object data, modify an object's data, update only the required object without affecting other subject. Keep the code organized and reusable. To access and update an object's attribute, we use self.attribute name. Example, updating a student's grade, that is class student def init self comma name comma grade. Self dot name is equal to name. Self dot grade is equal to grade. So def update grade, that is self comma new grade. Self dot grade is equal to new grade. Print. So let me run this code in ideally Python. So here let me get the another lines too. So the output for this example code has been displayed in the interactive mode. So students carefully see to the program. So now I am going to change the ideally cell that which gives the output, that is Alice grade is updated to A. So next, that is constructor init does the initializes the student's name and grade. Then self.name is equal to name, self.grade is equal to grade. Stores the value inside the object. Method def update grade self comma new grade. This method updates the student's grade. Self.grade is equal to new grade. Changes the old grade to the new grade. Print f. Print f self.name, then Grade is updated to self.grade. Displays the updated grade. Method call. Student1.update grade A. Student1 automatically becomes self. A is passed to new grade. The object's grade changes from B to A. Key points. Methods can modify objects, attributes. Self.attribute access the current object's data. No new object is created, only the existing object's data is created. Then each object maintain its own independence. Real life example. Think of a bank account initialized that is balance is equal to with 10,000. Then after depositing it is 2,000. Then balance will be like 12,000. The account is still the same object only. Its balance attribute has changed. This is the exact how methods modify object attributes in Python. In Python, every method can specifies the in special first parameter called self, which refers to the object that called it. So let us do. That is the syntax, let me give it. So now the task is car class is defined with attributes brand and color. A car object car1 is created with brand Toyota and color red. The program prints the old color, takes a new color as input and prints the updated color after repainting. Your task is to define the repaint method inside the car class. It should take only one argument, new color. Update the object's color attribute to new color. Print a message. So let us do the coding. So let me move to the ideally shell and open the interactive mode. So let me change the slide. Your class car is to def init self comma brand comma color then colon then self dot brand is equal to brand then self dot color is equal to color then def repaint self comma new color then colon then self dot color is equal to new color print self dot brand, then repainted to self dot color. Then a instance is created, that is object of car 1 is equal to car car Toyota, then color is red. Then print F old color of self sorry carbon dot brand, then carbon dot color, then new color is equal to input new color, then carbon dot repaint new color, parenthesis close. Then print updated color of carbon dot brand, carbon dot color. So F5. See students, the output of this code has been displayed successfully. So you can go through the code and check the output according to you. So let me give blue. So here Toyota repainted to blue, updated color of Toyota is blue. So you can also do various programming here. So let me show you another example, that is giving another example, that is to define a car class, define method self set name with two arguments, that is self and name. Then define method by name get name with one argument self with returns the name of the car. Then create one instance of car and name it as Honda. Hint Honda is equal to car function. Take name of the car from the user, call the method set name on Honda instance and send car name as argument. Call the method get name which returns the name of the car. Then print the name of the car. So let us do the function together. So let we take the script mode together. So here def set name sorry set name, that is self comma name, then colon, then self dot name is equal to name, then def get name self, then return self dot name. Then here we have to give the object, that is Honda is equal to car. Then car name is equal to input car name. Then Honda dot set name, that is car name. So let us run this code. Car name Toyota. Honda car name is Toyota. So the output has been displayed perfectly in the script mode. You can check the script mode and by the program given. So next, that is Python way of method overloading. Overloading is the ability of to behave in different ways based on the parameters that are passed to the function. Method overloading means the ability to have multiple methods with the same name, which vary in their parameters. It is the one of the concepts in polymorphism, but Python does not allow this kind of overloading. That is, multiple methods with same name is not possible. In Python, we can create a method that can be called in different ways. In a single method, we specify the total number of parameters and depending on the method definition. We can call it with 0, 1 or more arguments. The body of the method contains the logic of what we need to be done in the case any parameters of the method is absent. This process is calling the same method in different ways is called method overloading. This kind of overloading is not supported by many OPP languages, oops language, but Python allows it. The overloading method, that is, let me show. Class, class name is to name is to def method is the, so I'm giving now the syntax. Later on we'll be practicing with the real life codes. Then wish is equal to none. Statement, then statement, then statement 1, then we can give number of statement, that is let me change the statement up to n. So after that, you have to give the object, sorry, object 1 is equal to class name. Then object 1 is equal to, sorry, object 1 dot method, then function call. Then object underscore 1 dot method 1, then that is ram. Then object underscore 1 dot method 1, then that is ram. Good morning. So this means the same method can be used 0, 1 or 1, 2 arguments. The body of method 1 contains the logic code of what needs to be done. So let us go with the example. So let me move to Python script mode in ideally shell. So let me open that. So here class greetings, then def say hello, that is self, comma, a is equal to none, comma, b is equal to none. Then if b is not none, print hello plus a plus b, then parenthesis close. Then else print hello plus a. Great is equal to greeting, then a is equal to input, b is equal to input, then greet dot say hello of a, then greet dot say hello a comma b, then f5. So 5, sorry, how are you? Hello, how are you? So this is the output of this code. So let's check the function and see to the output which I am displaying now. So next, that is modularity. Modularity is the act dividing a program into individual components is called modularity. The justification for partitioning a program is that it reduces its complexity to some degree. It creates a number of well defined documented boundaries within the programs. Inheritance. It is the process by which an object of one class acquires the properties of objects of another class. There are several reasons why inheritance was introduced into object oriented programming languages. The main reason is reusability. One can derive a new class from an existing class and add new feature to it. It ensures the closeness with real world models. Another reason is transitive nature. If a class A inherits properties of another class B, then all subclasses of A will automatically inherit the properties of B. Polymorphism. It can be defined as the ability of single entity to behave differently depending on the context. It has the ability to take more than one form. That is, an operation may exhibit different behaviors in different instances. So, next, that is, inheritance is implemented by creating a derived class that can have the features of the base class, in addition to having features of its own. In real time, it is more of the parent child relationship. A child generally has the feature of the parent and has the addition of new features. Car is a base class, parent class, which can have an engine, tires, etc. Honda Accord can be a derived class or a child class that is a car first, which has an engine and tires, and also has features like ABS and color. A base class is created just like a regular class. So let me give the syntax of a base class. That is, class base class name is statement 1 to statement n. A derived class is created by passing the base class name as a parameter to derived class as shown below. So class derived class name, that is base class, that is, you can also change like this. Class derived class name, inside parentheses you can give the base class name. After that, you can give n number of statements. So you could have understand the syntax of the derived class. A base class can be in same module or another module. If it is present in different module, then the module name followed by dot operator precedes the base class name and it is passed as the parameter given that I am showing now. Then next, that is, I'm going to show you example, that is in the ideally shell in interactive, sorry, in the script mode. So Let me open the ideally shell and shift the screen to ideally shell. So here class car, then def set engine model self comma engine self dot engine is equal to engine. Then def get engine model, that is in parentheses you have to give only self. Then return self dot engine. Then you have to declare another class, that is class Honda. In that you have to give car. Then here also you have to def set car model, that is self comma model. After that you have to give self dot model is equal to model. Then after that you have to give def get car model, that is self, then return self dot model. Then you have to give the object that my car is equal to Honda. Then my car dot set engine model, that is EK minus 1. In next statement you have to give my car dot set car model as VG. Next you have to give the print statement where you have to print the car details. Print my car dot get engine model. Then the last print statement, that is print my car dot get car model FI. So see student, you can check the screen where I wrote the whole function, that is in class, that is created the instance of different objects. So let me show the output where I got the output in the interactive mode. Then the next, that is understanding the superclass. Superclass, also known as a base class, is the class that provides common attributes and methods which can be inherited by other classes. It serves as a blueprint for its subclasses, allowing code reuse and better organization. The class being extended is called the superclass, and the class that inherits from it is called the subclass. Defining a superclass. A superclass is the defined just like any other class. It usually contains general properties and behaviors that can be shared by multiple subclasses. So let me give an example. Multi-level inheritance is also possible in Python. What is multiple inheritance? It is a mechanism through which features of the base class and the derived class are inherited into a new derived class. It is like grandparented parented child relationship. The kind of inheritance can go up to any level. So let us see the example here. So grandparent class, name age, then get name, get age. Inheritance, student, that is parent class. Roll number, department, get student detail. Then from here the inheritance is employee, that is the child class, where you will get the employee ID, get salary, then get employee details. Explanation. Multi-level inheritance is a type of inheritance in which one class inherits from one class to another. Then a third class inherits from the derived class. In simple words, class B inherits from class A. Class C inherits from class B. This creates a chain of inheritance. Because of this chain, the last class can access the properties and methods of both the parent and grandparent class. Real life example. Imagine a family. Grandfather to father, father to son. The son inherits characteristics from father. Since the father already inherited characteristics from the grandparent, that is grandfather, the son indirectly inherits those characteristics as well. The same concept is used in Python. Python example. Suppose we have three classes. Person base class stores common information. Person class have name, age, get name, then age. From there, it is inherited to student derived from person. Add student related information where student derived class has the information like roll number, department, get student details. From there, it is also derived, also inherited as the third state, that is employee. Add employee related information. In employee derived class, employee ID, salary, and get employee details are stored. Inherited chain. Person to student, student to employee. Here, student inherits everything from person, employee inherits everything from student. Since student already inherited from person, employee can also access the members of person. What can employee access? The employee class can access from person, name, get age. From student, they can access roll number, department, then get student details. Own members, that is employee ID, salary, get employee details. Visual representation, you can see the simple basic mind map of this one. Then advantages of multi-level inheritance. Code reusability reduces duplicate code, easy maintenance, better program structure, easy to extend existing programs. Key point. In multi-level inheritance, the child class inherits from the another child class, forming a chain of inheritance. Therefore, the final derived class can access the members of all its ancestor classes, making code reusable, organized, and easier to maintain. So, moving to an example, that is, task is to write a Python code that creates an instance of the address class, takes input for a person's name, age, and address, then uses the appropriate methods to set and get the attributes. Make sure to call the get name, get age, get address methods to print out the information after getting it. So let us move to the ideally cell where we'll be trying out the full code with any errors. So let us open the script mode in Python shell. So after opening, let me change the screen to ideally shell where you can see the before code. From here, class, person, then def, set name, then self comma, name, then colon. Then self dot name is equal to name. Then we have to give another function, that is def get name. With that parenthesis you have to give self. Then print self dot name. Then from here you have to give the class student. In that you have to give person. Then in that you have to give def set age self comma age. Self dot age is equal to age. Then def get age, that is self, then print self dot age. Then again you have to create another class, that is class address. Where you have to store the class student in the parentheses. Then def set address as self comma place. Self dot place is equal to place. Then def get address of self, then print self dot place. Then we have to give the s1 is equal to address. Then name, then name is equal to input. Then age is equal to int of input. Then place is equal to input. Then s1 dot set name name. Then s1 dot set age, that is age. Then s1 dot set address is place. Then S1 dot get name. Then S1 dot get age. Then the last function call, that is S1 dot get address. Then give FI. Ashwin 18 Tamil Nadu. So the output will be multi-level inheritance is also possible in Python. What is multiple inheritance? It is a mechanism through which features of the base class and the derived class are inherited into a new derived class. It is like grandparented parented child relationship. The kind of inheritance can go up to any level. So let us see the example here. So grandparent class, name age, then get name, get age. Inheritance, student, that is parent class. Roll number, department, get student detail. Then from here the inheritance is employee, that is the child class, where you will get the employee ID, get salary, then get employee details. Explanation. Multi-level inheritance is a type of inheritance in which one class inherits from one class to another. Then a third class inherits from the derived class. In simple words, class B inherits from class A. Class C inherits from class B. This creates a chain of inheritance. Because of this chain, the last class can access the properties and methods of both the parent and grandparent class. Real life example. Imagine a family. Grandfather to father, father to son. The son inherits characteristics from father. Since the father already inherited characteristics from the grandparent, that is grandfather, the son indirectly inherits those characteristics as well. The same concept is used in Python. Python example. Suppose we have three classes. Person base class stores common information. Person class have name, age, get name, then age. From there, it is inherited to student derived from person. Add student related information where student derived class has the information like roll number, department, get student details. From there, it is also derived, also inherited as the third state, that is employee. Add employee related information. In employee derived class, employee ID, salary, and employee get employee details are stored. Inherited chain. Person to student, student to employee. Here, student inherits everything from person, employee inherits everything from student. Since student already inherited from person, employee can also access the members of person. What can employee access? The employee class can access from person, name, get age. From student, they can access roll number, department, then get student details. Own members, that is employee ID, salary, get employee details. Visual representation, you can see the simple basic mind map of this one. Then advantages of multi-level inheritance. Code reusability reduces duplicate code, easy maintenance, better program structure, easy to extend existing programs. Key point. In multi-level inheritance, the child class inherits from the another child class, forming a chain of inheritance. Therefore, the final derived class can access the members of all its ancestor classes, making code reusable, organized, and easier to maintain. So, moving to an example, that is overriding. Overriding is the ability of a class to change the implementation of a object provided by one of its ancestor. Method overriding. It is a very important aspect of object-oriented programming since it makes the inheritance utilize the full potential. It allows to change the implementation of a method which is inherited by the child derived class from the parent or base class. The following conditions must be fulfilled for method overriding. The concept of inheritance must be pre-existing in the program. The presence of parent or base class and derived class or the child class inherited from the parent base class. The method which is redefined in the child class must have the same signature as in the base class. Note, we cannot override a method in the same class. So let me show a example for you. Animal is equal to dog. Then animal sound dog. Then sound is overridden. Python program. Class animal def sound self. Print animal make sound. Class dog animal def sound self. Then print barks. Print dog barks. D is equal to dog d dot sound. So here the second will be printed here. Dog barks because the sound method already exists in the animal class. The dog class defines the same method again. When sound is called using the dog object, Python executes the child class method instead of the parent class method. Example 2, that is vehicle, that is car. Vehicle start, then the overridden is also start. Program. Class vehicle def start self. Print vehicle starts. Then class car vehicle def start self. Print car starts using a push button. Car is equal to car start, that is start. Then here output will be like the second statement will be printing off. Key points for beginners. Method overriding is possible only through inheritance. The method name and parameters must be same in both parent and child classes. The child class redefines the method according to its own requirement. When an object of the child class calls the method, the child class version is executed instead of the parent class version. Simple definition. Students, you can note this. It will be very understanding and useful for your level. So let us move on to the OOPS concept, that is data hiding and encapsulation. Let us recall what we have learned previously about OPP language. Object-oriented language has evolved to overcome the limitations of procedural programming approach, where data was available everywhere. Data is the given highest priority in object-oriented programming, and it is hidden to avoid irrelevant usage by function that can accidentally modify the data and thus produce erroneous data. One of the most fundamental concepts which provide data hiding in OPP are data abstraction and data encapsulation. Data abstraction refers to the act of representing essential features without including the background details and explanation. Consider the example of a switchboard. You can only press certain switches according to your requirement. What is happening inside, how it is happening, you need not know. This is the abstraction. You only know the essential things to operate on switchboard without knowing the background details of the switchboard. Data encapsulation is the way of combining data and function that operate on the data under a single unit. In this, data is not accessible to outside and directly. So it can be accessed only through the member function. This insulation of data from direct access by the program is called data hiding. Then, abstraction and encapsulation are complementary concepts, where abstraction focuses upon the observable behavior of an object and encapsulation focus on the implementation that gives rise to this behavior. Then, the last and the final motto of this lecture, that is data hiding, that is public or private access modifiers. An object-oriented program can be restricted to access the methods and variables which prevent the data from being modified by accident. The access modifier support are private. A private variable can only accessed by method that is the same class and not outside of the class. These variables start with underscores. So underscore underscore engine or underscore underscore model name. A private method can accessed only by other methods within the same class. Such methods start with two underscores. So that only I told underscore underscore. Then def underscore underscore set model name. Second one. A public variable can be accessed from anywhere. A public method can be called from anywhere. There is no specific word or character to represent the public access modifier. Anything that does not have a double underscore is a public variable or method. Example, you can see that is def of show of self. This is the function where public access modifiers are given. So here the oops topic comes to an end. So let me give the advantages of inheritance: code reusability, less code duplication, easy maintenance, easy extension, better program organization. Then moving to advantages of encapsulation: data security, data hiding, better code organization, easy maintenance, controlled data access. Advantages of method overriding: customize parent class behavior, runtime malporism, improves flexibility, better code reusability. Then moving to disadvantages of inheritance, that is, tight coupling between classes can make debugging difficult. Deep inheritance hierarchies become complex. Small changes in the parent may affect the child classes. And I know you are struggling with your Viva questions. So let me give a basic Viva questions of 10. What is object-oriented programming? What is a parent class? What is a child class? What are the advantages of inheritance? How many types of inheritance are supported in Python? Name different types of inheritance. What is single inheritance? Then, can a child class override a parent class method? What is the difference between method overloading and method overriding? Then, what are public, protected, and private members? That's it for your sake. So, before we conclude this lecture, here are some practice questions for you. Try to solve them on your own without referring to the notes. The theory questions are: what is inheritance in Python? What is the difference between a parent class and a child class? Explain multi-level inheritance with an example. What is method overriding? What is encapsulation? Explain the difference between public, protected, and private members. What are the benefits of method overriding in real world applications? Then, three programming questions. Write a program that to demonstrate method overriding using an animal and dog class. Then, write a Python program to create a student class and inherited it into a graduate student class. Then, write a Python program to demonstrate multiple inheritance using father, mother, and child classes. So, thank you so much for watching our lecture 7 part 2 of our Python full course. In this lecture, we have explored some of the most important concepts in OOPS, that is object oriented language programming, including inheritance, method overriding, encapsulation. We started with inheritance, one of the core principles of OOPS that allow the one class to inherit the property and methods to another class. How it promotes code reusability, how it helps to write clean, organized, maintainable codes. Also, we have discussed about different type of inheritance. Next, we have discussed about method overriding, where a child class provides its own implementation of a method already defined in the parent class. Finally, we have learned about encapsulation, which and helps to protect the object data from unauthorized access. It has public, protected, and private members, and understood how encapsulation provides data security, and program readability. These concepts are fundamental to object oriented language and are widely used in real world software development. So make sure to practice all the examples and solve the practice questions to strengthen your understanding. So if you found this lecture helpful, please like the video, share it with your friends, and subscribe to the channel so you don't miss the upcoming lectures. In the next lecture, we will see the file handling in Python. So also that we will handle the exception handling and abstract classes and interfaces with practical examples. Until then, keep coding, keep practicing, keep learning. Thank you, and I will see you in the next lecture. Happy coding!